Let's talk about this question. We are given that starting from rest, a basketball rolls from the top of the hill to the bottom, reaching a translational speed of 9.1 meter per second. There's no friction. So what is the height of the ball? And the moment of inertia of the ball is given as this is actually 2/3 mr square, and the acceleration due to gravity is given as 9.8. All right, so since there is no friction, we can say that the energy is conserved. So what we're going to do is, on the top, when the ball is there, is this is how it is, and it reaches the bottom, and the ball is rolling. Ball is rolling. Over here, the translational speed is given as, the v is given as 9.51 meter per second. We need to find this height from where it is released. So we're gonna conserve the energy. So to conserve the energy, initial energy is just potential energy. Let's call this A, and let's call this point B. So at A, we just have the potential energy, and at B, we have the kinetic energy. So kinetic energy will be the rotational, and the kinetic energy will be the translational as well. So for the potential energy, that's going to be mgh. Let m be the mass of this ball. Kinetic energy rotation is going to be I omega square over 2, and translation is going to be half mv square. Let's substitute the value of I. I is given as 2/3 mr square. So m is the mass. Let's assume the mass is 2 over, because we are representing the mass by small m, so let's write small m over here. So 2/3 mr square times 1/3 omega square plus 1/2 m half plus half mv square. So m is cancelled from the equation. We are left with gh, and over here we don't have 1/2. That's 1/3. That's 1/2. So this 2 is cancelled. So we are left with 1/3 r square omega square plus half v square. Now since the ball is rolling, so there is a relation between the angular velocity and the translational velocity, that is v is equal to omega r. So we're going to use that over here. We are going to rewrite this as omega r whole square, because both of these are in square. So we are going to rewrite this as a single inside the parentheses and raised to the power of 2. So we are going to now replace this omega r by v. So that's going to be 1/3 v square plus 1/2 v square. All right, so gh is going to be over 6. This is going to be 2 plus 3 is 5, so that's going to be 5v square over 6. So the height is going to be, if we divide both sides by g, that's going to be 5v square over 6g. So v is already given now, 9.51. So we're going to replace v by 9.51 and replace g by 9.8. So let me grab my calculator. This is going to give me the final value uh, of h. So this will be in SI units, because everything is in SI units. So 9.51 square times 5 over 6 over 9.8. So it's going to come out as 7 point, let's use a different color here, 7.69, and the height is in meters, which is the SI unit. So this is the required value of the height from which the ball is released. Thank you.